Hi guys, welcome to this page of the notes, and I know this is a page we actually just talked about, but there's one quick thing I want to go over with you before we move on to a couple more problems, and it's this. I actually made a slight little error. I told you previously that this a squared and the fourth root of a squared is as far as you can go. Actually, I'd like you to go a little bit further, and let me show you how. No. 2 is not evenly divisible by 4. However, something very interesting happens here that you do need to be able to do, and this is what it is. If I were to take and divide, let me rewrite this guy, come right up here to do it, as an a squared, and then I would have a to the 2 over 4, right? Because what I can do is rewrite this as an exponential expression, right? So the index becomes the denominator. Well, 2 divided by 4 turns out to be a 1/2. And that's actually really important, and here's why. So I have an a squared times a to the 1/2 when I reduce 2 over 4. But we know what the 1/2 power is. Remember, the 1/2 power is a square root. And so actually what I want you guys to be able to do on this one is just watch out for this when you simplify your expressions to a radical expression. If the denominator, or if the power is not evenly divisible by the index, and it doesn't come out to be a 1/2, then there's no further you can go. But in this case, 2 divided by 4 wound up to be a 1/2, which we know is just a square root. And so you absolutely should be okay with taking this all the way to the square root, to a squared times a square root of a, where that 2 becomes the index, but we don't have to write the index because a 2 is implied. And if you would prefer to write it this way, the square root of a times an a squared, so that we don't mix up this 2 and what the index is, perfectly fine. Multiplication is commutative. Doesn't matter what order you write those guys in. Those are essentially the exact same answer. I'm really sorry about that. I apologize. You do need to be able to recognize that if your power divided by the index comes out to be a 1/2 or a 1/3 or a 1/4, we'll rewrite that as that radical. So let's jump on to a new one here. This is the next page of the notes, and what we want to do is we want to simplify the expression that I've given you here, and right away we recognize that we have division. Now what's going to happen here is there is the quotient property of exponents, which says if you have the same base top and bottom, you'll subtract the exponents. Well, let me go ahead and rewrite this guy first, and then we'll see what happens from there. I have an 8th root, so I'll rewrite this as 81 to the 1/8 power. 81 raised to the 1/8 power over 3. My index is a 6, so that'll be to the 1/6 power. Now again, remember I just mentioned the way the quotient property of exponents works is this. If you have the same base, top and bottom, we can subtract the exponents. Well, I don't have the same base, at least not yet. Turns out, and you can use your calculator to kind of figure out what these are going to be, because they'll always work this way. In this chapter, in the homework, or on a quiz, or on a test, if I give you a quotient, all right, I'm looking for you to be able to use this technique. So what's going to happen is you'll always be able to either rewrite the numerator or rewrite the denominator as the same base, just raised to a different power. It turns out that 81 is 3 raised to the 4th. So I'll rewrite this as 3 to the 4th power, but that 81, which is 3 to the 4th, was already raised to the 1/8, so don't lose it, all over 3 to the 1/6. Now we're doing really good, but another property of exponents was the power property, which says that when you have a power of a power, you multiply the exponents. So I'm now going to have a 3. 4 times 1/8 would be 4/8. All over 3 to the 1/6. Well, now I have my common base. I have a 3 top and bottom. So I'll be able to subtract the exponents, but before I do that, I want to reduce this fraction. 4 divided by 8 is going to be 1/4, so 3 to the 1/4 power over 3 to the 1/6 power, and because I have the same base, top and bottom, we will subtract the exponents. So 3, it's always top minus the bottom, so 1/4 minus 1/6. Well, in order to subtract fractions, you need a common denominator. And I don't have one. I have a 4 and I have a 6. So I need to find the least common multiple of 4 and 6 and get my denominators to be that. Well, the least common multiple of 4 and 6 is 12, right? Least common multiple of 4 and 6 is 12. Well, in order to get a 12 here, I need to multiply 4 by 3. So I'll multiply top and bottom by 3. And so I will have 3 over 12 minus. To get the 6 to be a 12, I need to multiply it by a 2. But whatever I do to the bottom, I also have to do to the top. So I'll multiply top and bottom by a 2 to get my LCM of 12. So this will be a 2 over 12. Now, because I have that common denominator of 12, I can subtract these fractions. Subtract the numerators. 3 minus 2 would be 1. So I wind up with a 3 to the 1 over 12. Okay, great. Well, here we go. I'm going to rewrite this guy, right? The 12 becomes the index of my radical. And so I wind up with the 12th root of 3. All right, so again, what we've got here, and it'll work this way every time I give you one of these problems. If you see a fraction, the bases are not going to be the same. But with a little bit of work, you'll be able to rewrite it so that the bases are the same. You'll, of course, have this power property, so you have to multiply those exponents together. It's going to wind up getting you down to this, where the bases are the same, and we can then subtract those exponents. Actually, I apologize. Oh, I'm so sorry. I can see already I made a quick mistake. Hang on. Let's fix that mistake. Let me get rid of this because that's going to be all wrong. All the way up to here, I goofed. Hence one of the issues with you guys watching live math. I said, and incorrectly, 4/8 can be written as 1/4, which is crazy. I pull a 4 out of both, and this actually would be rewritten as a 1/2. So let's do this again. This would be 3 to the 1/2 power. I'm glad I caught that. All right, so 4 divided by 8 leaves you with the 1/2. Now my bases are the same. We subtract exponents. So that's going to be 3 to the 1/2 minus 1/6. Well, now I need a common denominator, but my LCM is a 6. So I'll multiply top and bottom by 3. So that'll give me 3 raised to the 3/6 minus 1/6. Subtract the exponents, and so I wind up with 3 minus 1, which would be 2/6. So 3 raised to the 2/6. Again, I apologize for that. I reduced that fraction wrong, and so I wound up with something incorrect. 4/8 reduces to a 1/2. Subtract the exponents. You need to find a common denominator, which of course would be 6. That's my LCM. So I multiply top and bottom by 3, which gets me 3/6. Now I have that common denominator. Subtract the numerators, 2. Keep the common denominator, which is 6. And now we can rewrite. Actually, hang on. That simplifies. 2/6 will reduce to a 1/3. Awesome. And we know what 1/3 is. I take the denominator, rewrite it as the index, and I have the cubed root of 3. That's going to be as far as you can go with that one. Again, I apologize about messing up that exponent. My bad. I'm just glad we caught it. All right, here we go. I got another one for you right here. I want you to take the 4th root of 9z squared. Well, let's go ahead and do some rewriting. I'm going to split these guys up, take the 4th root of 9. 9 does not have a perfect 4th root, right? There's nothing that when you raise it to the 4th power gets you 9. Well, an irrational number, but we're not going to write irrational numbers. We'll just leave it as the 4th root of 9. I don't really care for writing irrational numbers because you'd have to round, and then it's no longer equal to. It would be approximately because you rounded. So let's not bother with any of that. We'll just leave it as a 4th root of 9. But then let's multiply by the 4th root of a z squared. Well, I talked about this just a second ago when we started this on this page of the notes, when I went back to a previous problem where I had made a mistake and I didn't go quite far enough. Here it is. 4, I'm sorry, my power is 2, my index is 4. So this is going to wind up being a 2 divided by 4. So we'll have a 4th root of 9 multiplied by z to the 2/4 power. But 2 divided by 4 is 1/2. So we'll have a 4th root of 9 times z to the 1/2. But we know that the 1/2 power is just simply a square root. So we have the 4th root of 9, which I'm going to leave as the 4th root of 9 because it's an irrational number, and I don't want to write out an irrational number because I'd have to round, and that's kind of pointless. And then the square root of z. I don't need to write the 2 because it is implied. The index of 2 is implied, and so I just simply write the square root of z. And that's going to be for us as far as we go. Since I don't want to write the 4th root of 9 as an irrational number, we'll just leave it like that. Guys, I have one more example problem for you here when it comes to simplifying these rational expressions. And so head on over to the next page of the notes. We'll take a look at that problem, and I'll meet you guys there.